And your loved ones are healthy and safe. My name is Randy Bell, and I'm the director of the Global Energy Technologies with the potential to reshape the global energy system. We'll be hearing from Michelle Brechtelsbauer, Director of Stakeholder Relations at the Energy Impact 100 platform that provides open source information intended to streamline. But before we get started, we have a quick poll and two administrative details. Barrier to nuclear development, costs, licensing requirements, the lack of the survey. Let me go to our admission stream. Second, after Michelle's presentation. So back to the program, and let me please welcome Michelle Brechtelsbauer to the Atlantic Council. Michelle, thank you so much for joining us this morning.
It is amazing to be here. Thank you so much, Randy, for having me on. Looking forward to it.
Always a pleasure to work with you. We're so glad that you're a member of our second cohort of Women Leaders in Energy Fellowship. So tell me, how are you doing during COVID and this never-ending semi-lockdown? It looks like you are actually in the office.
I am. Yeah, it hasn't been too bad for me because I have been able to come into the office, and COVID's actually been a little nice. We get to communicate even more with folks, and people are getting even more used to taking calls and Zooms, and that's actually been pretty good, especially for folks in a role like mine, where I'm speaking with stakeholders across the community and the energy landscape all across the world all the time.
That's fantastic. So it doesn't seem to have impacted the development timeline of your project at all.
No, not really. And our team has also been pretty used to working across technology spaces. We have two offices, one here in DC and one in Atlanta. So we're already usually on video calls constantly. So it's kind of been a pretty seamless transition, actually.
That's fantastic to hear. Well, why don't we get started with your presentation, and then I have a bunch of questions for you, and I know the audience will as well. So over to you, and we'll come back in a little bit.
Awesome. Let me start to share my screen. Okay. Can you see it?
Yes, we can.
All right, great. All right, well, let's jump right in. I have a lot of really cool stuff to show everybody, and kind of I'm excited to talk about this kind of new approach to innovation in clean energy. All right, so to orient everybody to who the Energy Impact Center is, we are a research institute based here in Washington, DC, with the mandate to accelerate the transition to clean energy on a time frame that can make a difference. Our vision is to significantly expand nuclear energy worldwide as a means to decarbonize global energy production and increase access to clean, affordable power around the world. All right. So our early research efforts at Energy Impact Center centered on understanding the relationship between energy emissions and climate change. We understand that to achieve deep decarbonization, it's not enough to just clean up the electricity sector. Future energy sources are going to have to provide industrial heat, help us produce clean synthetic fuels, and power direct air capture of legacy emissions as well. And that is why nuclear energy in particular is such a critical technology for us. It has an incredibly high energy density and low carbon footprint, meaning that it's really one of the only technologies we have available today to generate the vast quantities of energy that we need to not only meet global energy demand, but also account for its own life cycle carbon emissions. And so that is why it's been a primary focus of our organization. But despite the potential of nuclear energy as a technology, it remains underutilized around the world. It's stagnated at roughly 5% of global energy supply, and it's often overlooked in future climate policy or energy planning discussions. And to understand why that is, our organization conducted a critical review of the nuclear industry itself. Some of this was done through the work of the Titans of Nuclear podcast, which you might be familiar with, but lots of conversations with experts around the world who are looking at different pieces of the energy space and nuclear energy in particular. We've also conducted a techno-economic analysis of historical nuclear deployments, looking at the successes and the failures throughout the industry in the past several decades. And what we found wasn't an industry that was crippled by politics or public opinion or a lack of scientific ingenuity, but rather one that's been captured by this dominating trend towards larger and more complex infrastructure projects that has ultimately made nuclear power uncompetitive from an economic standpoint. So if you answered the quiz with cost, you can see where I'm going with this. Right. So our research has found that cost is ultimately driven by the speed and risk of construction, not the reactor core technology itself. In fact, we found that the most successful build-outs have happened in the 1960s in the United States, where, for example, a 600 megawatt project could be delivered in 3 years for less than $1,000 a kilowatt. But since then, projects have escalated in their size, and they now require custom and highly complex components and construction practices that only specialized vendors and EPCs, or engineering, procurement, and construction firms, can provide. And so what that's really done is kind of shrink the available supply chain and those who can provide the expertise to develop these projects. And what we now understand is that to revitalize the industry is going to require a whole new approach altogether. One where power plants are designed to fit today's capital, supply chain, and market constraints, and that can be brought online in the next few years, not decades. What we need is something that's small and repeatable, known technologies with known construction techniques, and a new business model to enable nuclear power to become commonplace. And so to bring this vision closer to reality, we've created the Open 100 project. It's an industry reboot of sorts to help reset the industry at a very, very critical juncture in time. So at its core, Open 100 is a platform that offers developers a blueprint with all the elements they need to design and construct a small nuclear power plant that meets those constraints. And it's all free, online, and open source. And so now I'm going to go to the website and show you around. So if you want to follow along or look at this later, the website is open-100.com. And essentially what it has is kind of 3 core elements, which I'll get into in a little bit. But first, I'll give you a bit of an overview of what exactly this platform provides. So like I said, Open 100 is a development template for a small power plant that's been open sourced. And that means that it's publicly available and there's no proprietary technology. The design is based on a standard pressurized water reactor, or PWR, which has been scaled down to 100 megawatts electric in size. And for those who are not too familiar with nuclear energy, PWRs are the most common type of nuclear reactor technology. And there's roughly 300 of these in operation around the world today, varying in size. To open up the supply chain and reduce capital risk, we've deliberately avoided the use of new reactor technologies or the use of new or unproven materials or non-standard equipment and components, anything that deviates from the standard supply chain. It's also been designed to be virtually site agnostic and have minimal environmental impact, meaning that it can be placed in virtually any environment through some specific and deliberate technology choices that we've made. All right, so let's dig into the core elements. So like I said, there's 3 core elements. Those are the engineering files, the construction, and the economics. So let's look at engineering first. All right, and I'll just open up a few of these just to kind of show folks the breadth of information that's here. If you see something that catches your eye, it's your favorite piece of technology, I would implore you to come back later and take a look for yourself. But I'll just click one of these now to kind of show you the type of information that's included on the website. So for each piece of equipment, you'll find a basic description, technical specifications. You're able to download the CAD file for each piece of equipment. You'll see some vendor options here, for example. And then, of course, there's also a video explainer that our engineers have put together for each of these components. Right. We've also opened up the construction schedule. Let's go to it here. And you can see both the pre-construction and the actual construction schedule itself. And they're in these kind of Gantt chart dashboards. So Open 100 establishes a construction timeline to match those of comparably sized industrial projects. We're aiming for a construction period of 24 months or 2 years from mobilization to completion. And as you can see, we're including specific targets around each step of the construction process for project managers to stay accountable to this timeline. All right. And then last, I'll show you guys the economics. So as we're doing all of this work, we're also gathering cost information for each line item of the project, so we can be as detailed as possible and provide a clear estimation of the economics. So in this dashboard, we have a comparison of a 100 megawatt nuclear power plant to a 1 gigawatt nuclear power plant. And the gigawatt size is what we most commonly see today. And so you can kind of compare the numbers. You can drill down in here. You can also drill down by specific items to see really where each of these costs are coming from, for example. And by prioritizing standardization and speed of delivery in the design, we've been able to show that costs can be competitive with fossil generation in virtually all markets. And the goal here is for the price point to enable access to traditional project financing. All right, let's go back to the slides for a sec. Okay, and I think I've covered this, so we'll do the next slide. All right, so why are we open sourcing this? By open sourcing this information, we are aiming to set a common foundation for the development of clean energy that we urgently need around the planet, and ultimately align stakeholders around a best set of practices. And it isn't just for project developers. Utilities may find use in using this information for feasibility studies. Startups don't have to start from scratch. They can leverage existing balance of plant work to inform their own designs. Investors can look at this information and have a more transparent baseline for evaluating economics and timelines when they're looking at new plant options. And in turn, what this aims to do is restore competition to the supply chain, increase financial transparency, streamline licensing, and enable multiple projects to be developed simultaneously. And now to answer a question that I know is on a lot of folks' mind. From the beginning of this project, we've been working in lockstep with the National Nuclear Security Administration, the NNSA, to ensure that everything that we're publishing is in compliance with export control laws and adheres to non-proliferation safeguards and standards. All right. Open sourcing has also allowed us to collaborate with scientific and industry partners around the world. Let me see if I can go back to this page really quick and pull up our collaborators who are contributing their expertise and experience to the project. Open sourcing also means this is very much a living project, and we're publishing everything as we go, refining the model based on the expertise and the input of our partners, as well as the expertise and input of those who are looking at this in terms of implementation or informing their own project development. This community, the Open 100 community, really understands the scale of the problem, and they understand the potential scale of the solution and nuclear's role in that solution. For nuclear to meet its full potential in addressing climate change, it's likely not going to come down to the next reactor design that's going to be the game changer, or even maybe the next 10 power plants that are built. we're really going to need is a community-wide effort that's focused on making nuclear energy cheaper, more accessible, and more abundant around the world. So that brings me to the business model. So our vision is to usher in a new era of collaboration and transparency, to breed a new generation of nuclear companies around the world. Those who aren't focused on just reinventing technology, but those who are embracing, this new development model. And the model that we envision is one that's based on the fundamentals of the real estate industry, where scalability and the success of your business is driven by efficient project management, and it doesn't rely so much on proprietary technology. Let me go to the next slide. So this is a departure from the traditional business model that we see in the industry. With the gigawatt scale projects of today, there's a combination of the vendor, EPC, utility, and government who take responsibility for bringing a project to life. But there's a conflicting incentive structure. Because projects are so infrequent, the normal objective of securing repeat business and delivering a project cost efficiently isn't effectively applied throughout the project's lifetime. And that means that the vendor and the EPC, who are motivated to maximize their profits, are often incentivized to allow for inflated costs once the government and the utility are on the hook and the project is deemed too big to fail. And that is really what has to change. We propose a more straightforward arrangement where in the long term, it's beneficial for all parties, where the vendor/developer takes full responsibility for the project. By keeping it small and simple enough, they're able to hold the EPC responsible for cost and timeline constraints. And where the government's role isn't so much in the area of offering direct financial assistance, but in ensuring that regulations and licensing are streamlined and stabilized to enable new development. And where the utility can offer a straightforward power purchase agreement, or PPA, like we see in the renewables industry today, where nuclear energy is valued for its stability, its energy security, and its environmental benefits. So the missing piece so far hasn't been advanced technology. We've had this technology for the past several decades. Rather, what we've been missing is a framework for developing a nuclear power plant that the developers and the customer, the utility, who aren't familiar with the technology can look at and agree to. And that's why we've created the Open 100 project. So in conclusion, and to touch on the theme of innovation, yes, innovation is necessary, but I don't think that we need to innovate just for the sake of it. We should focus our efforts on the right challenges to move this industry forward and democratize information. And in that way, we can unlock the innovation that we need to revitalize the nuclear energy industry and achieve our collective goal of a zero carbon future. So this is the Open 100 website, as I mentioned earlier, and I encourage everybody who's watching this stream to go to the platform on your own time and explore the resources that we put online. And with that, I am looking forward to answering your questions.
Michelle, thanks so much. Really, really fascinating. We are starting to get some questions in the chat and the Q&A, so please pose your questions there. I have a ton. I will try to limit it just to a few. I want to ask right off the bat the sort of obvious, perhaps sort of dumbest question possible, which is if I were to go and start my own island nation. And wanted to build a nuclear power plant, could I use these plans as they were? Or would I, as I assume, would have to actually do a lot more work and get a real nuclear company behind it and not just sort of hire some construction guys?
Well, I do not know your nuclear engineering expertise, Randy, so I'm not going to assume that you are.
Does not exist. There is no engineering expertise in this brain.
Yeah, so definitely you would obviously need to have some expertise to develop a project like this. But yeah, this will get you kind of more familiar with what you're actually dealing with, right? You'll understand, who you need to speak to across the supply chain, across, EPC contractors, and it'll get you kind of started. But I would not say that you're going to be able to build your own nuclear power plant on an island, or let alone in your basement with no expertise in this area.
Well, that is disappointing, but not surprising. Okay, so a question about the technology approach. At our Global Energy Forum in Abu Dhabi in 2019, so nearly 2 years ago, January, we had a panel on the future of nuclear power, and there was a big debate about whether there were going to be any new Gen 3 plants built, if really the world was looking at Gen 4 and SMRs going forward. Now, like Open 100 has really made the bet that there's still a future for Gen 3. And I'd like to hear, the thinking behind that. And just with also the understanding that there's a little bit of a similarity, though not the same thing as an SMR. It still is a construction project, which is different than an SMR, but it's a much more efficient construction project. So how did you think about like the technology you were going to use, and how that relates to sort of what technology is in the pipeline?
Yeah, so right now the nuclear industry is kind of at not a crossroads per se, but we're definitely at a turning point. Where we have this legacy of building these large power plants, PWR most of them, and we're looking at building a new generation of smaller designs. But we're right now, we're kind of in that interim period, and we have a lot that we can learn from the successes, the good parts and the bad parts of that previous model. And what we want to ensure is that when we're looking towards the future, we aren't just forgetting all of those amazing lessons learned, but we're actually using that to create a foundation for that next generation of technology. What we don't want to see is these new designs reinventing the wheel too much. What we're really trying to do is ensure that we have nuclear available to address climate change. And that we're going to need is this rapid development of small nuclear power plants in the near term as well as in the future. And that means that for the near-term projects, we're going to need to stick to proven technologies that can be licensed, that can utilize existing supply chains, and that have materials available today that can, be utilized to build them. And that's how we're going to actually achieve those cost reductions that we're talking about, by sticking to the supply chain and reducing that capital risk. With a lot of the new designs we see coming down the pipeline, what I worry about is that some of them are trying to do too much at the same time. So not just shrinking down the size, but introducing new unproven technologies. And every time you kind of deviate from that standard supply chain or even standard construction techniques, you're introducing new risk that can affect costs and the bottom line. So what we're trying to do is kind of keep it simple. We're going to change the one thing, which is making it smaller. And then we can innovate from there once we've gotten the cost equation correctly.
Got it. Thank you. We have a really good follow-on question from Seth Gray. I want to come back to the cost question, but a good follow-on question from Seth about where you think the first deployment might be.
So honestly, it could be anywhere. So this is something that I think someone like the NREC program might be very interested in, because they're really focused on proving out that nuclear can be developed quickly and cheaply. So there's definitely a place for in the United States. Beyond though, what we're really trying to do is let nations that either already have nuclear expertise or even those that are newcomers to it have something that they can really look at tangibly, and learn from as they're seeking building out their new build programs. So this could be something that a country that is looking to build an SMR or a small nuclear power plant in the next few years, next decade, would be very interested in.
Got it. Thank you. Are there countries that are actually talking to you about this? Or can you not say yet?
Oh no, yeah, no, we've actually gotten an overwhelming amount of interest in this, which is really exciting. And so, yeah, we're talking with utilities and governments around the world who are just wanting to learn from, the what we're putting out here and help kind of inform their decision-making processes when they're looking at new technologies, especially those that are kind of transitioning to having a fleet of existing, large-scale PWRs, and they're looking at how they can utilize their existing nuclear expertise and their existing companies and supply chains and suppliers to build smaller nuclear. And so this has been really helpful for countries like that.
Really fascinating. Okay, there are a group of questions around cost, so I think it's a good time to go to the poll. Roger, if you can show the poll results, I think no one will be surprised that cost is perceived to be the greatest barrier to nuclear development, though a number of other issues are also polling pretty high, but cost does have the majority of votes out there, which your plan attempts to solve. So first question is, what is the projected cost savings utilizing the Open 100 plan?
Yeah, so the poll is right. Well, the poll matches our own research, right? When we talk to experts, the thing we hear over and over and over and over again is it all comes down to cost. The other things that are listed on that poll often feel inflated when compared to cost, because it is such a big component of why nuclear is not being built today. So we are by utilizing standard construction techniques and the existing supply chain, we're looking at a cost of $300 million or less. And that's where we think the industry needs to be if it's going to access the type of financing that will be critical for enabling this rapid development and simultaneous development of new projects around the world. I'm talking about private capital sources. I really sympathize with the financing piece of these larger projects that can be $5 to $10 billion. But that means you have to turn to governments for specialized rates and loans, and that really takes the burden off of the product developer. No other industry has to do that, and nuclear shouldn't do it either. So what we really want to see is, if we want a scalable industry, we're going to need to fix the cost equation and fix the timeline and be much more on par with the other types of clean or not clean or technologies that governments are looking at when they're trying to meet their energy demand for their nation.
Got it. Okay. We are almost out of time. I want to close with two questions from the audience that will sort of pair together. One from an anonymous attendee who asks if the economics portion has been peer reviewed, and then a second question from Ann Kanavati, who asks if your project includes permitting timelines and what assumptions are made regarding how long permitting will take. So we'll end with those two questions.
Yeah, so the timeline does have permitting, but obviously that is something that will be country specific or regulator specific. And so, one of the things we're actually doing is, as we bring on, more new collaborators, we're looking to expand the number of collaborators we have around the world who can bring in that type of expertise for understanding how permitting would go. The timelines that we have online are only for the construction. They aren't for, like regulatory processes. And in terms of the cost, so it's informed by, we're getting real vendor quotes for each of these components, and we're putting those into the models. So, as we're looking at designing, an aerator, for example, we're speaking with supply chain vendors in the US and abroad, and then we're actually comparing those to the costs that we're putting up in our model.
Fantastic. Unfortunately, we are out of time. Thank you, everyone out in the audience, for tuning in today. And thank you, Michelle, for this really remarkable presentation. I learned a whole lot. And though I am disappointed that I can't build a reactor in my basement, at least quite yet, I hope you will all join us for the next episode of Innovation Stream on Thursday, November 5th at 8 a.m. Eastern, which will feature Will Gardner, Chief Executive Officer of Drax Group, who will discuss adding carbon capture and storage to biomass generation at the UK's largest power station, so creating a carbon negative power. You can also join us for several other events in November. November 10th at 9 a.m., we'll host an event to launch the U.S.-Europe Energy Bridge, which is the next evolution of USAID's energy sector assistance in Europe and Eurasia. You can register for both these events and more at the Atlantic Council website. Thank you to everyone who helped put this event together, including Mercedes Sapupo, Roger Morales, Emma Smith, and Olga Kokova. This presentation will be available on the Atlantic Council website, YouTube channel, Facebook, and Twitter. So please do share it with your colleagues if you think they'll be interested. Thank you again for everyone for joining us. Michelle, thanks so much. We're so glad that you're part of the Atlantic Council family. Looking forward to seeing everyone virtually